This is Professor Fernandez. We're going to talk about class note C in lesson 7. And just to review what's going on here, we just had introduced the notion of a constant coefficient, second order linear differential equation. There it is. That's what it looks like. And here we are down here. This is me trying to indicate that, if we want to try to solve these types of ODEs, the form of the ODE itself is a clue as to what functions might be in the solution. And the clue here is that the unknown function y is literally related to its derivatives, first and second derivatives, by these numbers. And I say in here, there is definitely one function that we know behaves that way, and this is sort of the teaser to what we will do in this class notes. So the one function that we know behaves that way is the exponential. So we are going to let y of t equal e to the rt. We don't know what r is yet, and you might be wondering, why do we need the r? If we just let y be e to the t, then the first derivative of e to the t is e to the t. The second derivative is also e to the t. So we would end up getting an equation that looks like a plus b plus c equals 0, which would mean that e to the t would solve this type of system only if a plus b plus c equals 0, which is not true in general, right? We could find many examples where e to the t would then not solve the ODE. So by putting in an e to the r times t, that is going to allow us to get a more general condition that will yield solutions to this ODE. All right, so let's see how that works. So if we are letting y of t be e to the rt, then what's going to happen? Let's calculate the quantity that's on the left-hand side of the ODE. So I'm actually going to start from the right and work my way left, because that way I can do the differentiation with you. So here's y. I'm putting it in over there, multiplying it by c. Then I'm going to add, the next term is by prime. So the derivative of e to the rt, I need a chain rule for that, brings down the r. Great. And then the last term, I'm going to do y double prime, which is the derivative of y prime. So again, I'm going to use a chain rule there, bring down another factor of r. So I get an r squared e to the rt. Great, and each of these terms has an e to the rt. So I'm going to factor that out, leaving me with this. Okay, and then I'm going to say, so if ar squared plus br plus c equals 0, then ay double prime plus by prime plus cy equals 0. Right? Makes sense? So if this part equals 0, then I have e to the rt times 0 equals 0. Okay, so my conclusion is that, therefore, if y of t equals e to the rt and ar squared plus br plus c equals 0, then y of t solves ay double prime plus by prime plus cy equals 0. Okay, and that's actually what I wrote down here, slightly worded slightly differently.